So scientific notation, hopefully you guys are familiar with seeing this form, but you're going to have, if you have a really big number or a really large or a really small number, you're going to move the decimal so that you have a one-digit number, well, one integer in front of the decimal place. And then you're going to have it times 10 to the however many places you moved the decimal. So that number should be an integer. And I don't worry about if you move left, the number is positive, whatever. Just remember, if you have a really large number, your exponent should be positive. If you have a really small number, your exponent's going to be negative. That's an easier way to remember that, I think. The word must not be connected. Hold on. Nope, it's not. So let's write down these problems. So if we write it in scientific notation, what's that first number in scientific notation? Right, 3.292. Now when you write scientific notation, for us, we look at significant figures also. How many significant figures are there in this number? 4. So we need 4 in this number. So we don't want to put those extra zeros there. So we're here times 10 to the what? 1, 2, 3, 4, 5, 6. Or you could count 1, 2, 3, but I need 3 more zeros. So that'd be 6. How about this next one? Do you guys have this one? Oh. What was that? Times 10 to the negative 5th. Yep. Negative, because this one's a really tiny number, so our exponent's negative. Here. 1, 2, 3, 4, 5. Okay, how about the next one? It only says 4.932 times what? Negative 3 or positive 3? Positive 3, because this number is big, so we want our exponent to be positive. And then that last one. .84 times 10 to the what? This one's negative 3, yep. This one's grams, and this one's kilometers. Good. Questions on switching stuff to scientific notation? How about if we go backwards, where we're given scientific notation, we want to write out the number. What would this number be? We're going to move the decimal left or right? Right, because this is positive. So we'd have 239 with 6 zeros behind it, right? Because that'd be 1, 2, and you need to move 6 more to get 8. Next one, are we going to move it left or right? Left this sign. So we have 3 zeros, 8, 4, 7, 3, 9. Because let's check how many significant figures are in this number. Down here. 5. Yep, 5. And then if we look at our number up here, how many do we have? 5. So we have the right number. Okay, how about that next one? What would it be? 1 0 to the right. So 5,350. Yep. And the next one? And you can put a 0 in front of the decimal point. That's fine. You don't have to. Whatever you want. Okay. So hopefully that's fairly, well, let's review, hopefully. And then we're going to look at proportions for the last part of the chapter. Basically what graphs, what kind of relationships different variables have and what kind of graph it would look like. So direct proportions is when the independent variable increases and the dependent variable increases. So we're going to have a linear relationship, and you could use the slope of the line equals, or the line equation would be y equals mx plus b. So as one increases, the other increases also. Inverse proportions is if one variable increases, the other variable decreases. We'll look at some different gas laws that will be like this later. This little symbol just means proportional, so y is proportional to 1 over x, so they're inversely proportional.